Following on from one of the most recent and most popular posts on the Metron website blog is regarding the top 10 performance metrics for VMware. These metrics cover CPU, memory and disk I/O. If we start with CPU, the first CPU metric that you should be monitoring is the average amount of CPU usage in megahertz. Firstly, VMware provide that metric directly from their software. Also, you could report in average CPU in percent. So for megahertz, you'll be looking to report this metric based on whether you have homogeneous hosts within your clusters. If you don't have homogeneous hosts within your clusters, then you'll be looking at using the percent metric. But what it actually tells us is it gives us an indication of the CPU usage and gives us an indication of any CPU bottlenecks on any host within your cluster. So if you're looking around the 80% mark at a host level, then that could be indicating a bottleneck on your host itself. But you also want to be reporting at the guest level, because then you can stack up the guest usage to find out whether most CPU usage is going on within your guests on each host. The second important CPU metric that should be monitored inside your VMware environment is called CPU ready time. CPU ready time gives us an indication of the CPU overcommitment within your cluster. What is CPU overcommitment? Well, what happens inside a VMware environment is that you have to schedule virtual CPUs onto physical CPUs. So a guest virtual machine has to run on a physical host. So when you assign a number of virtual CPUs to a guest virtual machine, they have to be assigned or co-scheduled onto each physical CPU. So if you have a four virtual CPU machine, it has to have 4 free physical CPUs available to run. CPU ready time indicates where this overcommitment takes place. Overcommitment is where you've scheduled too many virtual CPUs to the number of physical CPUs on a host. This can indicate bottlenecks and could degrade performance within your guest virtual machine. Okay, so moving on to memory metrics. The first memory metric, very similar to the average CPU usage, is the average memory usage, both on the host and the guest. So we want to have a look at how much memory is being used on the host, and then stack up the guest memory usage and see who are the heaviest users to indicate any bottlenecks. If there are any bottlenecks found on your host, take a look at your ballooning and swapping metrics as well to indicate if any of those have been invoked by your VMware ESX host. Okay, the next memory metric you should be monitoring is balloon. The balloon driver is installed by default when you install VMware tools in all of your guests. And when you report some values for the balloon driver, it indicates a memory pressure within your host environment. So the memory demand has risen to the point at which it has to invoke the balloon driver inside your guest operating systems within your virtual machines to relieve that memory pressure inside your environment. Swap used in kilobytes. Again, this is a native memory metric from VMware, and it indicates that actually that memory demand has increased to the point at which it starts to swap out processes to your vSwap file. This can seriously degrade the performance of any applications running inside your guest operating systems within your virtual machines. What you're also likely to see at this point is that if you have DRS enabled, it will be heavily migrating virtual machines across your cluster. Okay, the final two memory metrics I'd like to talk about is consumed memory and active memory. Consumed memory is the amount of granted memory that you allocate to your virtual machines, aggregated together, minus any memory shared. Unlike CPU, you can actually over-allocate memory within a VMware, and that's supported by things like transparent page sharing, ballooning and swapping. This metric also shows you how much host physical memory is being used and includes values being used by VM kernel. Active memory tells you how much memory is actively being used by the guest virtual machines on your host. When reporting the active and consumed, what you want to see is your active memory lower than your consumed memory for your virtual machines. Now onto disk I/O. So the first one we're going to look at is queue latency. This is the average amount of time taken per SCSI command in the VM kernel queue. The value should always be 0. If your values are not 0, it can indicate that the workload is too high and the storage subsystem cannot process the data fast enough. Kernel latency is the average amount of time in milliseconds that is spent by VM kernel processing each command. You should see values somewhere between 0 and 1 milliseconds. If you have values greater than 4 milliseconds, the virtual machines on the host are trying to send more throughput to the storage subsystem than the configuration can support. In this case, check your CPU usage and increase the queue depth or storage. And finally, device latency, which measures the average time in milliseconds to complete a SCSI command from the physical device. Depending on your hardware, a number greater than 15 milliseconds indicates there may be a problem with your storage array. If this is the case, move the active VMDK to a volume with more spindles or add more disks. So, that's my top 10 VMware performance metrics. I welcome any comments on what your top 10 are that aren't in mine.